Today, on October the 6th, we're going to be conducting an experiment regarding capacitance, right? Materials for this experiment, we're going to need two of these discs, we're going to need a meter stick, we're going to need a multimeter, a red cable, black cable, a computer, and preferably some pen and paper. We're going to go ahead and separate these two discs as far as we can. Get the measurement in between these, which is 23 centimeters. Get the systematic error, which we get by measuring it in the multimeter, right? And we're also going to go ahead and measure the area of each of these discs, which we end up getting a 0.283 meters squared. To get our theoretical values, we're going to go ahead and plug in each one of these numbers into a state equation that we already have. It's going to be the 5. I forgot. What does the E stand for? The dielectric constant?
Constant, yeah.
So we're going to go ahead and multiply the constant by the area divided by the distance between these two discs. Go ahead and plug these numbers in
There you go.
Perfect. So in the first step of the experiment, we put some distance between the plates. First we started at 1 millimeter, then 3, 7, 11, 17, 21, and 30 millimeters. We measured the capacitance, so we got the measured capacitance from the multimeter. Then we calculated it into the corrected capacitance and compared that to the theoretical capacitance and got the percentage error. For all of them, we kind of got pretty high percentage errors, but we were told that that's okay. And we just went ahead and filled out the table. So in the second step of this lab, we are going to go ahead and look for K, right? The way we're going to go do that is multiply the distance times the corrected capacitance, which is going to be it's going to be this capacitance in the multimeter minus the systematic capacitance that we got earlier. And then we're going to go ahead and divide that by the dielectric constant times area of the disc. We went ahead and used two different materials and then both materials at the same time. And we plugged in all the data.
Thanks for the materials. Wonderful.
And that's only if we use the acrylic one? I think it'll be a small.
Okay. And question for you, right? Will the equivalent capacitance be greater or smaller than the dielectric?
If he was about to jump up and I went like that,
So we're going to be using in step 4 the data from table 3. We're going to go ahead and calculate the theoretical capacitance using the measured and corrected capacitance, and the values that we calculate for dielectric constants are going to give us a value for the stuff with only capacitances and stuff with only dielectric constants, right? And we're going to go ahead and fill out a table including the theoretical capacitance, the equivalent capacitance using measured capacitances, and the equivalent capacitance using calculated constants. Yes.
Nice.
Thank you. So for the last step, step 5, we go ahead and measure and correct our capacitance with one dielectric in between the plates. And then we're going to calculate the percentage error with each of the theoretical capacitances. So the experimental value that we got was 28.9, but we did it as 29.1, giving us a percentage error of 6.2% with theoretical CA and theoretical CB giving us hold on guys, 66%.
Nice.
Awesome. Thank you.